Hello, hello. Another coding session. So last session we did a bit of refactoring, and I want to do a bit more. There is actually a fair bit of refactoring I have in mind. I have been avoiding refactoring. I hope I'm not repeating myself. I can't remember what I said in the last video, but I generally try to avoid refactoring in this series because I don't know, maybe it's nice to watch, but I thought, well, one of the opportunities in that this series has given me is like to stay on track, you know, to keep moving forward with the project, because sometimes I have a tendency to get stuck in refactoring and not getting anywhere real. But some of the features that I'm trying to implement at the moment are proving really difficult with some of the current structures. So that's why I feel like I have real reason to refactor now. And the kind of refactoring I want to do is actually to bring the code a bit more in line with the grammar, I guess you could say. So hopefully through the whole process of the compiler, you can still relate it back to the grammar as directly as possible, and it all makes, you know, it should be still quite clear. That's the goal. And you can do that at the same time as making it easier for new features. So it's a win-win. So what I want to do right now is I have opened my types file for AST, and one of the node types is type, which was kind of my way of figuring out whether an identifier that I'm looking at is a value or a type. But I don't really like that. I mean, and kind of one of the things in this language that I've done is said, you know, an identifier is an identifier. It could be identifying anything. It could be a procedure or a value or a type or anything, but it's just an identifier. So I kind of want to get rid of this. I actually want to replace it because at the moment, all these different kind of types that I have are all identifiers, but some of them, it doesn't really make so much sense for them because they're not really identifiers. I'm going to call these complex types. I think I'm going to make some more lists in here. So complex types is going to be another list of node types. This is a new list that, yeah, I mean, it's got all values that don't actually exist yet. So like I'll make an enum type. Let's just try to think of all the types that all these complex types. So generally complex types are types that are not just a single value, but they describe, you know, like a struct is a container for other types. An enum is like a limited set of types. What else is there? A procedure is like a container for like it's a container for like a set of parameters and a set of return types. Well, we can only have a single return right now. What else? I'm going to say a module is a complex type. So it's like a container for things. Let's see. We'll start with that. I think there's probably more. So we're going to need to add these to the list. Element of PQ. I love to put things in order. If you've watched many of my videos, you will know this. Everything has to be in order. Procedure type, module type, LMNO module. Why are you unindenting? That's kind of annoying. Struct type. That one didn't. Okay. So we have these, at least so far. And with those, it does mean that we're going to, so there's a lot of places where currently, if I look in the code, there should be a lot of places where there's just like an identifier, which is enum in square brackets. So instead of that, anywhere where we see that, we're going to convert that now to enum type. And same with the other ones. That's basically it. So if I look for, actually if I look for like, oh, I need to change my keyboard layout. If I look for this pattern, so we have like module procedure struct return. That is actually like a special identifier. That's fine. Bang C. This is actually like usage for compiler flow pre-post procedure enum. None is like a special identifier. I guess we can leave it as a. Or could we, maybe we'll make that, it's not really an identifier. Maybe this one also, maybe we'll make a none type or an untyped. Or an unknown type. Maybe like an unknown type. Parameters, values, and there's like groups. Main procedure, do we have any float? These any types. They're not really identifiers either, so maybe these any's should also be. Yeah, because really it needs to be an identifier. So there's like any float, any number, any int. There's any string. Okay. Maybe to like break things down a bit and not try and do everything at once, let's leave the any's for now. But let's leave the any's and the none. I think I think it makes more sense for them to also be switched over because they're not identifiers. So I want any node that has type.identifier to really have been an identifier in the source code. That's what an identifier is, right? I think. Okay, so let's start by moving these ones across, and we're also going to have to look for anywhere where type was used and fix that up. So if we look for enum, so instead of value equals enum, we're going to say type equals enum type. That's basically the kind of conversion we need to do. Like so. And this one is also, enum type. Oops, enum type. And there's some switches we need to take care of. This here, it's like type equals enum type, and then we don't need the value anymore. This is when we're actually parsing an enum type, so we're creating the AST. This is another equality, so this is case.type, so we need to fix this up. But maybe we'll do that later. We'll just do these replaces first. Okay, so here this is, I think, creating the type name. Yeah, we're given any type node. It's creating the name. So I already have like based on the type. So let's turn this into a switch. I do like my switches. We're going to need to make it partial because it's on an enum, and we don't want to implement all of them. So for a reference, we want to do this. What is up with my indenting today? It's kind of annoying. So if I do that, okay, it's going to do the right. So this is also node type subscript. So put that in there. And then we have enum procedure struct. So, oh, is that it? Enum procedure struct. Yeah, I just took one bracket too many with me. So let's take off that bracket. That was extra. And then here is case enum type. This is case procedure type. Down to here. Oh boy. And this is case struct type. And let's just make sure these are in alphabetical order, because that would just be terrible if they weren't. It would be outrageous, is what it would be. Okay. So I think that takes care of them, and it looks like we have some further down, so let's have a look at this. This is some dot type stuff by the looks of things. Yeah, I guess that's where the errors would be, right? What we're changing right now is not really errors. It's just the way we interpret things has changed. Okay, this is type var name. So this is very similar. It's just like a different way of it's like, so this type name is like a human readable type name, and this type name is like a type name that can be used in the output code, the generated code, assembly or whatever. So we're doing something very similar here. Oh, I should probably say that we're making a switch. Oh, these are all just the only things they have here. I think we can take that out. Or can we? I'm a little bit confused about this indenting. Oh, I think it's because of that. Okay. So this needs to change to enum type. Procedure type. Oh, so this is the type that we're switching on. And struct type. And then let's add these two as well. So reference would go here. So let's change that to a case. Like so, and then subscript would be the last one. Whoops. Yeah, I think that takes care of that. And 2 byte size. So here we also have enum's procedure struct, getting the size of these certain things. But also up here we have this similar thing, you know, where we decide based on the types. So let's elaborate on that, turn it into a switch. So case reference is address size. Subscript is more complicated. And then we want to add Oh, we don't want to take this out because there's other things also. So put enum here. Enum type is size 8. So take that out of there. Procedure can go here. And these are the same, so why don't we just put them on the same line, and then struct. So struct would go in here, like so. Cool. Okay, let's move on to the next one. Let's say procedure. There's quite a few places, I noticed this when we did the last one, where it's kind of just like equality checks. So let's say wherever we see like this, let's go like this. Replace all. And I think there was some not equals as well. Yes, not equals. So replace those. And now let's look for just procedure again. So there's not much left. So here we're creating a procedure type node. So we just need to give it the correct type. While we're here, we can also see that the parameters was a type. Let's make it a group. The idea behind groups that I just introduced recently is kind of like, it kind of relates to the grammar in that anywhere where you have a sort of a comma-separated list of things, then that's considered a group. And parameters, like it's a comma-separated list of things that you put into your procedure. So that works nicely. Here again, we'll call this a procedure type. When we're creating the procedure, go like this. And here, this seems to be the GLSL type name. Interesting. Oh yeah, I guess it's converting it to a GLSL native name. So we're saying that these are unsupported. Interesting. We're also saying that if there's a subscript, then we can do that. Let's again change this into a switch. So it's going to be like a nested switch. So subscript is something, and also identifier is something. These are identifiers. We didn't really explicitly say that before, but now we do. And that's the subscript, so that should replace... Why am I doing this in this tiny window? Let's open this up. So I think this if else is all taken care of now in this switch. So if we come across an identifier, that we just treat it like this, and a subscript we treat it like this, but this is no longer an identifier. So this is a procedure type. Oh, which is unsupported, apparently. So I think, and we didn't really deal with it properly. Well, oh no, okay, so we just use value for things that are not. Okay, so we do have explicit, we put a procedure type here and we'll say that's unsupported, and so are these. I think we can just make these single lines, right? Like so. Okay, so that's procedure done. What else did we do? There was module and struct type. So let's have a look for module. Module's kind of special, so I imagine it's probably in different places. Still have these quite a lot of equality and inequality checks. So if we go equals module, replace that with equals module type. And we have a not equals, just one. Okay, let's do it anyway. And where else do we have module? So here we're creating a module node, it looks like. So let's just call this module type. And here we have, okay. So here we have a switch on the value with those two, but I think, see here we're also checking the type for subscript. So really this could be changed into a single switch. So it's actually on the type. So this becomes the subscript, module struct, subscript case. Like so. And these are obviously the module type and the struct type. And so this if else doesn't need to exist anymore. Come all the way to the bottom of this and go like that. So that's actually a bit simpler. We only have to do a single switch instead of a if else and a switch. Kind of nice. Okay, where else do we have a module? Another similar place. Is this also, yeah, so this is also going on type. It's like if it's this type, otherwise do this. And it's only module instruct again. So I think we can do a similar thing. Let's take this if, cut it out, put it at the bottom. Oh, we need to take the brackets off of it and make that case subscript. And that becomes struct type. Why is that unhappy? Oh, because it needs to be type. And module type. That's why it didn't autocomplete. Okay. So module, we explicitly do nothing. And I think that's because our default case is to throw an error. Yeah. Default has an assertion. All right. So that's module taken care of. The last one was struct. Okay, doesn't look too bad either. It looks like we have equality and inequality checks. So we want something like an equality, struct, and then equality is again just one, but whatever. We'll do a replace all style. And where else do we have, whoops, where else do we have struct? This is where we create a struct type. This is also creating a struct node. Oops. And we still have a few more. Well, this is a case switch statement that only had struct in it. If is slice, so if it's an assignment, so if type subscript, type is not subscript, then we have a trouble. Okay, so this is compound literals. There's kind of like two cases for compound literals. compound literals either contain assignments or they contain just values. So this side, I'm going to say it's the type, and cannot do that. So this is going to be struct type. I think I want to do another one of these things where I sort of combine them. So because this slice thing is for, it's like a subscript thing. So subscript, and within that we check if it's a slice. And validate something. And I guess, oh, so we can take that out. And I guess the idea was previously, and we'll keep it as that, if it was not a slice, then there's no validation to do. Yeah, slices only contain two elements, which is the raw pointer and the length. But the other case is that it's an array, in which case, I think arrays you don't enter here at all for arrays, so that's all good. Cool. Where else we got this? Struct. Let's just close some of these. So this is also in compound literal. Yeah, something similar. So this is like, if it's a slice, do this, otherwise do this. So actually, because we're saying if it's a slice, do this, otherwise if it's a struct, or something else. So do we validate? I think we validate first. No, we don't seem to prevent. So compound literals can only be used for arrays, slices, and structs. And then when we get into the branch, which is not assignment, or which is assignments, I think that's only structs and slices. So I think actually that at this point we should deny arrays. So we kind of need this error. So maybe it's like this. If it's an array, then we throw an error. Otherwise, we know it's a slice, and we can do that check. So I think arrays should not come in here. If that's not true, I'm sure we'll find out pretty quickly when we try to run some code. So I think that's pretty safe to have made that change. But is that what we were actually changing right now? I'm getting a little bit lost. Yeah, I think this is what we actually changed. But this is where we were looking at changing. That's right, and I was just trying to make sure that up here we denied arrays. So down here we know that it must be a slice or a struct. That's like the only options. Because this is doing per member. It's kind of doing per member checking. All right, so let's... I feel like it's kind of consistent to do. Would it be type node.type? Yeah, I think so. So here we know that it's a slice already. We don't need to check because we already denied arrays. And case struct. Go here, and that'll be this. oops, that'll go up here. And why not keep this default case just as a bit of a sanity check. There we go. Looks good to me. So struct is still used in one more place. This is the compound literal for x86-64. So this is generating a compound literal. Here we check if it's an array, and if it's not, then I guess it's a slice. I don't know. And yeah, arrays and slices are only non-assignment ones. And now, so here, because we've already done type checking, we know if it's not a slice, then it must be a struct. So I think, I mean, we kind of made this assumption up here already. Oh no, we do assert that it's a subscript. So we do still have these sanity checks in here already, even though type checking should have taken care of it. It's kind of nice to just have a little bit of verification in here. So let's parcel switch on the type. Case subscript. Can go, oh my lord. Let's not do that, because that sucks when you have to reformat it manually. And I'm not really sure why it wanted me to do that either. Let's take these. They're already in switch format. Cut that out so that things are still formatted nicely. Ah, that still does it. No, I just want the word break. Ooh, why is it doing that? If I do that, no. God damn it. Screw it. Not sure why it's being such a dick. But it does, like, the syntax highlighting is dying, so something I think is actually messed up. But let's just, maybe it'll become clear once I, oh man, this is painful. Once I clean this up. So that goes there, this. Where does that go? Ah, okay. Now it's more happy. So I wonder if I can just like XV. Okay, good. That auto formatted it. Phew. So we don't have the slice case. So we put this in here. This is the slice case. That goes there. Should we have a sanity check that it's not an array? Maybe. Let's just say if it's an array, then we have trouble. Cool. And we can take out this empty if now. So struct is not used anywhere, but we have a lot of this dot type, right? Yeah, a lot of this is not actually it. If we say space dot type, then we will come across a lot of errors. So a lot of these, like all of these, are actually identifiers. This one's a group of parameters. But these are all just symbol types, you know, these are all just identifiers. So let's replace, just to be sure I don't replace too much, go like that. Make them identifiers, replace, cool. These also, remember init and stuff, these are ones that I did want to make special types for, but baby steps. We'll get there. Yes, so any string, this is any float, any number. None also I would like to make a special one for, but not yet. So that'll be identifier. So this is performing type checking of an enum type. This whole switch case is on the type. So we could just, you know, go like this. It's part of the switch. I think we do need to be careful now because there'll be a lot of other types that can come in here, right? Those other new types. And I guess for those we do nothing. So enum type. Oh, this is not alphabetical order. This is more of a, I think this is more of a grammar order. So if we're like looking at a primary, I think the types come at the end. Yeah, enum, struct, procedure type come at the end. So I think in here we would put these above this default case. I think that's where it was anyway. So if I put procedure type, oops, struct type, and do nothing for now. I don't know if that's right. What are we doing here? Type checking. So we don't need to type check these. Well, this enum one is checking for duplicate members, which I feel like is also totally relevant for structs. And I think there was a missing check before. Procedure types. Yeah, I don't know what to do here. We'll just do nothing for now. It's fine. Okay, so I think that's looking pretty good. This is with the space, right? So I think we don't have too many, but let's see if we can get rid of some of these, get rid of some low-hanging fruit. You know, these are just identifiers. That's just an identifier. These ones are identifiers. But also some of these, I kind of wonder, so this is in generation, it's an i64 node that we're making. But I think now, because we have the program in the context, and we know that it should be in that list of identifiers, i64. The simple types are all in the program. So we should be able to do that. I feel like that's better than creating the new node. We don't have the rest of those now. Yeah, we changed a few that I would like to not be changed like that. I think they were all in generation. So if we go space.identifier, which is what we changed it to, and we reduce the scope to generation. Yeah, here we go. These ones, what next? These are kind of some, like giving some semantic, yeah, it's more semantic, like they're saying, you know, a U64 identifier, an index type node, so it's giving it more meaning. So I think that's fine. We'll leave those. What's this? So this one, we create this node to pass into here. But I think we can just directly put this here like this. And yeah, I'll keep it as a separate line. Okay. Down, oh, so that's those two. Was that it? I guess I didn't do many. Okay, cool. That's an easy one. That should be a group. These are identifiers for now. Saying identifier or type, well, that would just be identifier now. Something I do want to be a bit careful here. Why did it take me up there? So identifier. This also is like this. Well, we do have this as type, which we need to change. So I think that should cover it. I'm not sure if this is still going to work. This would be an interesting thing to think about. Let's leave this for now. So this is actually the primary type we're talking about here. Yeah, there's going to be a few places where the dot type is actually a primary type. So yeah, that's a primary type. This is saying identifier or type if it's a member. So I think we should be able to just take that off. That should be fine. Type equals is, yeah, so this is type. We're going to have to look at this a bit more carefully later. Generate primary. So we have like do nothing for types and also don't go into children for types. So maybe we'll just go something like this. If the current node is a type, then don't do anything. Yeah, you never generate type. I think that should be safe. Let's see. Maybe not. We will find out. Defaults to an expression. I'm also curious if those new type nodes come in here. I think, wow, well they won't because they will be considered types. This type will catch it. This type will catch it. Okay. So I'm happy with that. Let's put the grammar over there. This one we needed to look at more closely. There was something else we also wanted to look more closely at, but I can't remember what it was. This here is where because initially when we tokenize, at that point we don't know whether it was identifier type, and then during parsing there were some cases where we could figure out at that point, it's a type. But we don't need to convert these to type anymore because this is another one, because that's not a thing. So it's a bit of a simplification there. This is the primary type, I want to say. If I go to the top here, what's a big one? Yeah, I think this is parse primary. Yeah, and type is a primary type. Is type. That was the other one that we wanted to look at more carefully. Okay, so this is GLSL primary. So this is similar to the, oh, this is that. I thought we removed this. Okay, strange. Okay, oh, it's part of primary. Okay, yeah, that's why it has dot type. Is type. So this is x86 version of primary. So we did have this thing here. So this should never actually happen. We shouldn't need that check. And we shouldn't need this case either because we already jump out here. Okay. What is this? This is making a Boolean node. I guess we're in generation. Yes. So here, like we did in other places, we can do context.program identifiers. Ooh. And that takes care of that. A bit cleaner. This is parse primary, parse primary, parse primary. Okay. What is this actually? Is that right? This is some SOA stuff. I think this can just be identifier. But this, I don't remember this code, so I could be totally wrong. Resolve placeholder. What is placeholder? Is placeholder just checks that it has a prefix of $. So let's just take, well, should we say identify? I mean, identifiers are the only things that could possibly have a prefix of $. So I'm just going to take that off. I think that's fine. So we are cutting it down now. So this is type. That's the primary type actually. This part we're not sure of, and this part we're not sure of. Okay, so we're down to the actual difficult parts. So is type. What I want to do differently here is, oh, I found a new, I also can't remember if I said this in the last video, but I found a new slice procedure called contains. I don't know why it took me so long to find this. But if I do like complex types and then type, that's better than what I had been using was linear search, but that returns 2 values. So then you have to like grab the return values and then do an if. So this is more inline. It's a little more simple. I should convert my slice searches to this where possible because it's cleaner. So if it's a complex type, then yeah, it's a type. If it is one of these, then we need to check whether it's a reference or a subscript of a type. I was going to say and then lastly, but I don't know if then lastly is. My tendency with these kind of things when I'm choosing which if to do first, oops, is like this is just 2 checks, so it's very quick. This is checking in a list, so it's a bit slower. And I'm going to call this simple types. So if we're looking at an identifier and the value is in simple types, then that is also a type. So simple types, if we go back here, so we have complex types. Simple types is going to be a slice of strings, because these are identifiers, right? So actually, currently in type checking types probably near the top. Yeah, we have all these lists. I think I'd like to move them to AST, but for now, let's just take like numerical types. So we'll have the full list here and the partial lists there, just because I don't want to do even more refactoring. So there's numerical, which would include these, all of these, but there are more. So we also need like any string. We need none. And we need like bool. I don't know what else we need. Is there any other non-numeric types? I think that might be it. Because like string and C-string and things like that are actually aliases. If we look at the globals file, we can see they're just aliases. So I think that's about it for simple types. So then, yeah, if it's a simple type, so this is how we know if something's a type. It's either a reference or a script of something else, which is a type, subscript of something else, which is a type. It's a complex type, or it's a simple type. That's it. Okay. That takes care of that. This last one, where did it go? If I try to run, it should be the only error, hopefully. This one I'm not so sure about. I mean, this whole resolve type things I don't like. I want to fix this up. I mean, this is more or less get identifier node. Isn't it? Like this is saying if it has an identifier as a child, then it seems to be assuming, or I guess it's checking here whether that child is a module. And if it is, then it gets that, which is what we do already in getIdentifier node. And here we use getIdentifier node. I think this was written before I kind of put this in identifier node. So I'm going to try here just to like cut that out. That's a hell of a lot simpler. And now there's this thing where like we say it has to have been resolved if it had type already, which I don't like. I mean, I'm just going to try and cut this out for now and see what happens. I don't think good things are going to happen. Okay. Well, I guess we can put that in there, because to have a value, you need to have an identifier. And I think it's better to use has prefix, because that will check for empty strings. It'll handle empty strings. So I think it was not. Yeah, it does not have that prefix. So if that does not have that prefix, and it doesn't have this prefix. So these are the special types which are being reduced, and I want to remove altogether, and these are placeholders. So this here is basically saying placeholders don't have to be resolved at this point. Special types don't have to be resolved at this point. It's all good. Okay, let's see. Byte has not been declared. Wow. So if we go to globals, line 1, this is where byte is being declared, but it says byte has not been declared. I wonder if it's this line that I was unsure about. It is. So we're type checking the statements. We're resolving the types, which goes into the children. The first child was the left-hand side child, and it tries to resolve it. And I guess this wasn't a problem before because this should only happen for types. We might have to just take this out and handle it elsewhere. So we got a bit further. So now we are in our example code at line 23, and bar has not been declared. So it's saying this is not declared, but I think that's as a result of there being an issue here first. So that bar it's saying has not been declared. The interesting thing about that is that it should not really be trying to look for a declaration of this. It's a member. You don't look for declarations of members. I mean, if you were, the error would more be like, this is not a member of my enum. That's what it should look like. So how to handle this? Let's see. I think there's a couple of places where this error gets thrown, yeah. So I'm not so sure this time where it was. I mean, obviously it wasn't here anymore. So let's check. So let's get some context on this. So is member, does it know that it's a member? It thinks it's not a member. Interesting. Now something, yeah, I guess the idea behind this resolve types before. So it's only if it resolves to a type, then it will get replaced. The node will get replaced, which should be fine. But I do feel like this resolve types could be a bit more heavy-handed now. I do think that is type check should handle everything actually. So why does it not think this node is a member? So this is bar. So if it's a member, it should have a child. That child is an enum type. Okay. Right. So it's a member of the enum type, but I don't think isMember handles that. It does not. So there was this this guy here. So before we said like if it's not an identifier, then it can't be a member. So that's looking at the current thing, so that's fine. Then we dig deeper. We go through subscripts and references and dereferences. And I chopped this bit off before. It's an identifier or a type. Oh God. Where did I just jump to? Identifier or a type. So maybe I should bring that back. Let's just revert that. But instead of just saying it's the type of type, let's say is type. Are we already in the AST? We are. So we don't need that. Instead of looking directly for that. Okay. Does that help? Compound literal. Checking if the type node is an array. So it's a subscript. Has 2 children. Oh, I think we're actually, yeah, it's because the assertions run the wrong way. Yeah, because we want it to be raw in length, so we don't want it to be an array. So we're asserting that it's not an array. Yeah, that assertion was just backwards. Oh, okay. That worked. I knew it would. I knew it would, of course. Very confident. So I think we're going to close a bunch of these files, except for this one. Do we want to be brave and try the OpenGL example? That one did not work. Okay. Why did that not work? Checking if that's a type and it says no, when it should say yes apparently. So it's an identifier. The identifier is kernel T, which is a type. This is gel compute shader. So this is the actual OpenGL file here. So boomstick.kernel.t is a type. But it's not being identified as a type. It's an identifier. Does it have any children? It has 1 child, which is the identifier boomstick. So at this point, when we're type checking the compound literal, that type should have been resolved. Why was it not resolved? Now, another thing I remember, it's down here, when resolve types. Remember there's that big chunk of code that I cut out? And I said, we don't need this. This big chunk here. Do you think maybe we did need it? I mean, get identifier node already checks if it's a member and it doesn't have a data type. I'm not sure why that's a check. Oh, it's child. So it's a member of something, and the thing it's a member of doesn't have a data type. Oh, it does have a data type, and that data type is module type. Okay. Yeah, so it's checking that it's a member of a module. Which I feel like is basically what was going on here. It's saying you've got a child, which is an identifier or a type. And then it just is like, wait a minute. Identifier or a type? This is a bit weird. And then that identifier or type child node is then oh yeah, then we're checking whether that's an import. And if so, we go there and get the import, we get the identifier node from the import, check if that's a type. But if we go into here, so we've identified that it's a module that we're looking at. Because it needs to be module type. It needs to be module type. But it starts off as just an identifier. It needs to be changed to module type. So we have an identifier in our code. Let's look at the code again. We have this identifier in our code. Type resolution should figure out, oh look, here's the declaration of it, and it has a data type of module because this returns a module. Yeah, so that should be. So where are we? If we go here, we're actually getting the type name because there's a previous error even as well. So I was worried about the is type, but maybe this is actually more interesting. So the type node, yeah, I think it is still because the type node is just an identifier kernel T. Kernel T has not been resolved properly. Yeah, so I do feel like it's still a resolution thing. It's definitely not resolved correctly. So could that be this? Maybe there is, I mean, this code is different. No doubt about that. So if I bring this back, I think no, I thought I would need another bracket. Why did that not need another bracket? If I bring that back and just take this off, is that better? Does it then resolve the type properly? It does. Okay, so there was an issue here created by that. So this could mean, because I pulled this out, this could potentially mean that we're not catching that something is undercleared. But I think I'm going to leave this for now because I think, because we're over an hour already. I was hoping we would be able to get a bit more refactoring done because we have, don't worry, we have more to come. But I think some of the future refactoring that I'm planning in the next session or two is going to handle this. So I'm not too worried about like trying to get this right now. I think over the next couple of sessions this will work itself out. And this was the only question mark. This whole type resolution, type resolution as a whole is what I really want to get at. So we did this change. Next, I want to really solidify the concept of a scope. And then I want to really revamp type resolution. I have some ideas about that. I think I need to do a bit more investigation. Because right now, we immediately, we just clobber the current node. but I think I want to do more of like a lazy resolution. So we maintain the initial. I think the idea is that, you know, this would become get declaration, and then just at any point where we need to see the declaration, because the declaration includes like type information and allocator and stuff like that, then we just get it. I'm not sure, that might have some downsides, but I think overall it's going to be easier, and I think easier is good, and then performance later. Anyway, I think that's enough for me that those two examples compile after refactoring a whole bunch. So let's call it a day. Thanks for stopping by. Have a good one. Ciao for now.